Hi everyone, I'm Theo, and in this video I'm going to co-present with Shujaat our systematization of knowledge about research related to longitudinal privacy management of publicly shared personal online data, which is joint work also with Markus and Christina. First of all, I'd like to introduce our topic and motivate why there is a need for effective privacy controls in online environments, with particular focus on longitudinal aspects of privacy. The number of data people share in online social networks is simply incredible. This talk is going to be around 18 minutes long, and during this time, people from all around the world are going to share more than 1.1 million photos on Instagram and create more than 10 million tweets. Within this large amount of data, there are many posts that are not meant to be permanent. To this end, many applications already offer options for posts with limited data lifetime. For example, these platforms here, the ones I just referred to, allow posting contents that are available for 24 hours. In addition, many posts are not meant to be seen by everyone, which is why content visibility can be limited to specific audiences, for example followers only. However, the latter one, who can see content, can be either set at the moment of publishing, such as posting a photo, or when not manually specified, it is defined by the user's default privacy settings. The thing is, once data is out online, there is usually no adaptations of these settings, unless the user explicitly revisits and manually updates it. When we look into research related to managing longitudinal privacy, the vast majority of work is either on the user side, for example studies about users' reasons or perception in the context of data sharing, or on the technical side, where we see lots of proposals focusing on cryptographic aspects of data revocation. For example, one recurring idea there is that data is always published in encrypted form, making the decryption key inaccessible after some time. However, such proposals usually assume that there are no threats during data lifetime, for example that no one will store the unencrypted data or the key. So far, there is no taxonomy taking into account both the usability and the technical perspectives. In our systematization, we aim to point out to what extent the user's needs are fulfilled by technical mechanisms and to identify potential gaps between those two sides. In the first step of our systematization process, we collected a large body of literature from the usability and the security and privacy research communities. We defined a set of categories with different factors on each side. For the user side, this includes specific usage patterns that were studied, along with drivers for unsharing, that is, reasons that people have to reduce the availability of their contents, and desires they have in a data sharing context. On the technical side, we categorized proposals along the use cases they were designed for, the protection mechanisms that were included, and adversarial models that we consider. We aligned those two categorizations along usage patterns on the one side and use cases on the other side. In the next step, we identified conflicts between those two sides regarding the other properties, for example when there are specific user desires that are not properly addressed on the technical side. We distinguish 3 levels of conflicts, that is, incorrect, incomplete, and missing realizations. From those conflicts, we derived a set of challenges that are not properly addressed from our perspective. We arranged these challenges around 4 central themes regarding the expiration conditions for data that affects multiple users at the same time, we call data co-ownership, user awareness, and security and trust. In the remainder of this talk, we are going to have a look into each of these blocks, starting with the systematization of user studies first. In the user studies we considered, we identified 5 usage patterns related to longitudinal privacy management. The first 2 are about reducing the exposure of content in 2 different ways, actively and passively. Users can actively manage the audience of their contents, for example limit the visibility of a publicly shared photo to followers only. Passive methods include removing tags of other persons from a photo, which also reduces visibility since it will no longer be shown in this person's circles. However, in both cases, the content itself is not affected, it still remains online. Another usage pattern is deleting content. This is an explicit action users undertake, such as clicking a delete button. As a consequence, access to the content in the social network is removed. Alternatively, there's also automatic expiration, which has the same effect, that is, content being removed, but without the user being actively involved at the time of deletion. The last usage pattern is deleting the account, which means that not only a single piece of content, but all the content a person owns is removed from the platform, along with their online identity. So in total, there are 3 levels of escalation that have been studied so far. We identified 6 drivers for users to limit the visibility of their content. These include regrets that come up after publishing something, contents that become less relevant over time, and users changing their opinions about publishing contents without further specifying reasons. Moreover, there are cases in which external events make users revise their sharing decisions. Misconceptions when the exposure level differs from what users perceive, when they are explicitly asked about it, or users expressing fears that specific groups of people can see their contents. For their desires, users want on the one hand the visibility of their contents to be reduced over time. On the other hand, they do not always want content to expire automatically, but they also want to be reminded such that they can review and confirm potential deletion decisions. When it comes to relations with other people, users have some specific desires. For example, they would like to be able to also control contents that have been uploaded by others as long as it affects them. For example, when their face can be seen on a photo shared by a friend. Additionally, users express desires that the audience for something they share should be composed differently depending on the content they've shared. Related to this, there's also a desire for a user view, that is, a feature where users can view their own profile from the perspective of another user. We identified 33 relevant papers that contain studies about publicly shared data, whereas only a couple of them explicitly asked about longitudinal aspects of data sharing. However, also the other papers provide useful insight for our systematization. We categorized all papers along the different usage patterns, drivers for unsharing, and user desires, as explained before. For the technical perspective, we followed a similar process, which will now be presented by Shujaat.
Thank you, Theo. For the systematization of technical proposals, we start off by considering the use cases these solutions are designed for. Whether it is the deletion of content such that it is no longer publicly accessible, or reduction of exposure of content such that it is only exposed to a subset of audience. We also capture the number of data owners involved, as well as their level of involvement in the decision to revoke or restrict access to the content. We then rate the adversarial model of each technical proposal with respect to the following attacker types. If a proposal considers a specific adversary in their threat model, we label it as such. Retroactive adversaries learn which data they are interested in only after the data has been revoked. So the assumption here is that the attacker has no interest in accessing the published data before its expiration. Honest but curious adversaries act as a legitimate party in a protocol but will attempt to learn as much information as possible. On the other hand, interfering adversaries actively interfere by either preponing or postponing the data revocation event, and insider adversaries can control user devices and can compromise users' passwords. To realize these use cases and fulfill adversarial guarantees, each protocol relies on different technical means. The following protection principles have been proposed multiple times in varying realizations. These range from cryptographic mechanisms to deception and flooding to access control policies and so on. Let's now take a brief look at the systematization of 35 technical proposals that we reviewed. I will briefly highlight some important trends. We start off by providing the publication details along with the platform it is primarily designed for. Whereas multiple proposals were focused on specific platforms like Facebook or Twitter, quite a number of them were platform independent. As far as the use cases are concerned, majority of the solutions were directed at reducing visibility of the content, requiring no active involvement from the data owners. In terms of adversarial models considered, majority of the solutions assume that the adversaries are honest but curious, that is, they abide by the protocol but try to learn as much information as possible. For the protection mechanisms, we noticed quite a few proposals relied on both cryptographic primitives and distributed architectures. In these forgetting schemes, encryption keys are embedded into the stored data. In order to prevent single-point failures, these schemes avoid putting trust in a central authority for the storage of keys. Instead, they rely on distributing parts of the decryption key on distributed storage. In the backdrop of prevalence of AI systems, such as facial recognition, adversarial examples are increasingly being proposed to allow users to limit their content's exposure to these algorithms and thus go undetected. We also witnessed other mechanisms used less frequently, some of which include the use of intermittent withdrawals to guarantee the privacy of the act of deletion itself, and machine unlearning to teach AI systems to forget over time. Looking at the bigger picture again, once we categorize the user studies and the existing technical proposals, the next step involved conflict identification across these two sides of the story. Starting from the categories identified in either part of the systematization, we identified potential inconsistencies between them. Pursuing a user-centric approach, we systematically examined to what extent users' desires and their drivers for unsharing are reflected in the current state of technical proposals. We identified conflicts whenever realizations in technical proposals are incorrect, that is, orthogonal to users' desires. We termed a conflict incomplete whenever realizations in technical proposals are promising but far from satisfying users' desires. The last category of conflicts relates to missing realizations that do not address users' desires at all. By combining and contrasting knowledge from both of the obtained systematizations, we first identified conflicts and then derived challenges. We followed a bottom-up approach. First, we derived fine-grained challenges related to the conflicts, and then we put them into a broader context and related them to each other, resulting in a set of 4 challenge groups as shown here in the right. We will now take a look at some of these derived technical challenges. Let's consider an often occurring scenario where a social media user uploads a photo on their profile and have 2 options to choose from: to set a time limit for the photo to expire, or to not set an expiration condition at all. In the former case, for most end-user solutions like Snapchat, there is no flexibility as all posts expire in the standard 24-hour limit. Even in the cases of flexible expiration times, appropriate time for data deletion is often difficult to determine in advance. In the other case, where the user does not choose any expiration condition, the context in which data is published can change. Major life events such as graduation or moving to a new city could take place. It is also likely that the post sensitivity levels might evolve with time, rendering it irrelevant or even harmful to the data owner. Multiple studies have found that participants did not want contents to fade away wholesale with age. Instead, they showed desire for revocation to take place for only selected audiences. In contrast, the overview of technical side shows that the commonly considered condition for data revocation has been the time passed since publication. The decision on content's exposure control is a complicated one, hardly captured by focusing alone on the age of posting. To this end, we derive specific technical challenges, one of whom is to come up with an adaptive expiration condition that takes into account contextual factors, such as changes in life circumstances based on the data available to the platform. Similarly, the other technical challenge is to fully realize audience-dependent expiration, such that automated revocation decisions do not affect all individual users or groups of users, such as family, in the same way. Now, Theo will present another set of challenges.
Thank you, Shujaat. For data co-ownership, we also identified a set of potential conflicts. When uploading a photo showing multiple persons, such as a group of friends, to an online social network, the photo has one distinct owner, the person who uploaded it. Other people in the photo, who are also part of the social network, can be tagged in the photo, either by the owner or by the other persons themselves, or both, depending on their privacy settings. That means that their online identity, their profile, is linked with the photo owned by a different person, their friend. There are a few questions that can arise here. What can happen next is that each of these persons can change their opinion about the current exposure level, about to whom the photo is shown. Even the relationships between those persons can change. Each of these implies that there is a need for adaptability of the current level of exposure, preferably for each of these persons. Regarding the question who of them can take action, we see that their owner is the only one who is in full control of the photo's privacy settings and can, for example, delete it. The other two are limited to removing their references, but have no means to make the photo entirely unavailable, although their privacy is affected in the same way as the owner's privacy. So we see a certain level of power imbalance between users, and that should be addressed. There has already been some research in this direction. On the user side, there are different mitigation strategies that have been explored, even though not necessarily focusing on this exact setting. However, when users say that they avoid that photos are taken at all because they cannot control it when others share them, this shows that there is a serious problem in terms of power imbalance. There are different technical proposals, but those have never been validated in the sense whether they reflect users' desires. It is not clear if concepts such as voting mechanisms or automated conflict resolution can really provide individual users their desired controls. To this end, we formulated two challenges due to the missing and incorrect realizations of user desires in the context of controlling others' contents. Adaptability of exposure and handling power imbalance are two key challenges that need further research. While this was a first glimpse into the challenges we derived, there are a couple of more that we discuss in our paper, for example regarding user awareness and security and trust issues. We also reason about further issues that we did not formulate as explicit challenges, but that require attention as well from our perspective. In summary, we have presented a new taxonomy for managing longitudinal privacy in online social networks. We have seen several conflicts, for example that users desire more nuanced data exploration, or problems with power imbalance in multi-user scenarios that are not appropriately reflected in technical systems. To this end, we derived a set of challenges and open questions to be addressed by future research in this area. This is the end of our talk, and Shujaat and I are now happy to take your questions. Thank you for watching this video.